So now we're gonna discuss the second problem from day 5. So what's the problem states? We are given the head of the singly linked list. We have to return the middle node of the linked list. So we are given a linked list. We have to return the middle of the linked list. If there are two middle nodes, then return the second middle node. So we'll copy these examples in our whiteboard. Okay, we'll paste it. So this is one of the example, and the second example is this one. Paste it. So what is given in the question? We are given a linked list. We have to find the middle element of it. So how will you solve this question? We can find the length of the linked list. So the length of the current linked list is 5, and what we'll do, we divide it by 2, we'll get our answer as 2. And starting from index, we'll start a loop with a condition as I equals to 0, and when I become equals to the length divided by 2, we'll return it. We'll return the node. So what I'm saying is, let's suppose let's focus more on this condition. Let me delete this one and we'll come back later on it. So at this condition, the length of our linked list is 5. Okay, and when we divide the length by 2, we'll find the value 2, and we start a loop where we check the condition that our variable that is previously initialized with the value 0, if I is not equals to mid, and when I become equals to mid, we'll terminate the loop. Okay, this is what the condition is saying. So initially I points to 0, I is 0, and mid is 2. Is I equals to mid? No, it is not equals to mid. And in the loop we'll do one thing. There is a pointer CMP that is pointing to the head of the node, and we'll update it such that CMP is equals to CMP of next. That is, the CMP will now points to the next node, and we'll update I. Now I become equals to 1, mid become equals to 2, and our CMP is now pointing to the second node. Okay, is 1 equals to 2? No, it is not equals to 2. We will update our CMP pointer. Now it will point to the next node, and update our I. Now I become equals to 2, mid become equals to 2, and now the condition will violate and our loop will end, and now we are pointing to the middle node. Okay, so we're gonna check for the another test case. That is when we have two middle nodes. So this is the condition. Let me apply this condition, the same condition as we have applied for the previous test case in this test case. So we'll calculate the length of the linked list, that is 6. We'll calculate the middle of the length, that is 3 divided by 2, that is 3. So our mid is 3, and we'll check for the condition while I not equals to mid. At the starting, our CMP will pointing to the first node, and in the loop we'll maintain the condition that CMP is equals to, we'll make the CMP point to the next node and increase consecutively, increase our I. So at the starting of the loop, I is 0, mid is 3. Is I equals to mid? No, it is not equals to mid. We'll move CMP to this point, and I will become 1, mid will become 3. Is I equals to mid? No, it is not equals to mid. We'll again update our condition. Now our CMP will point to the next node, and we'll update our I. Now our I become equals to 2 and mid become equals to 3. Is I equals to mid? No, it is not equals to mid. Now what we'll do, we'll again execute the body of the loop, and our CMP will point to the next node, and we'll update the value of I. Now I will become equals to 3, and mid will become, mid will remains the 3. Is 3 equals to 3? Yes. Our condition of the loop violates, and our loop ends, and at the end we'll return CMP. So this is the approach. This is one of the approach that we can use to solve this problem. So now we'll look at the code of the discussed approach. So as we have discussed, we found the length of the linked list. We found the length of the linked list here. Okay. So this code is to find the length of the linked list. Okay. This code is to find the length of the linked list. Then what we'll do, we initialized our middle variable with the length of the linked list divided by 2, and use our secondary variable I, and our initially our temp pointer will pointing to the head, and we'll mm, make use of a loop, and in the loop we specify the condition when until our I become equals to middle, we'll update our temp pointer with the value of the next node and update the I, and at the end we'll run the temp. So we'll run the code and try to submit it. It had run successfully. So it has submitted successfully. So this is the approach that we use to solve the middle element, to find the middle element of a linked list. There is one more approach I want to discuss. So what's that approach? So what is the optimized approach to solve the problem to find the middle element of the linked list is that we'll use an approach in which we use two pointers, that is a slow and a fast pointer. And the characteristics of a slow and a fast pointer is that slow pointer moves one step at a time, okay, and fast pointer moves two steps at a time. So slow pointer moves two steps at a time, and fast pointer move two steps at a time, and we'll iterate over the array until fast points to null, until fast points to null, or what we can say is that until fast point to null, or fast of next equals to null, because it moves two step, and if it is present at this step, after moving two steps it will point to the to null. So we'll check if the fast points to null and the fast of next points to null. So it would be much more clear when I will solve the problem. So what we will do, I'll explain the test case. So initially our fast and slow pointers are pointing to the first node of the linked list. So what we'll do, we'll move slow by one step and fast by two steps. So our fast will be pointing to this position. Again, Again, we'll move a slow pointer by one step and a fast pointer by two steps. Now our fast will be pointing to this. Again, we'll move slow pointer by one step and fast pointer by two steps. So at one step it will jump to 6, and at second step it will jump to null. So our fast will be pointing to null. So we'll check the condition. We'll iterate over the linked list until our fast pointer points to null. Or let me mm, explain one more test case, then it would be much more clear for you. One sec. Then it would be much more clear if I explain one more test case. Let me copy this one. So this is another linked list. As per the concept, we have two pointers, slow and fast. Slow will move one step at a time. So at first slow will points to this and fast will points to this. Again, slow will points to this and fast will points to this. And we can see that if we move if we make our fast pointer moves two step, it will point to an element, that is how will make the two jumps, that is fast of link and link. And if we'll do fast of link, we'll get a null because the next element is null. And when we do when we try to access the link part of the null, we'll get a error. Okay, so we have to check the condition. If our fast has point to null or fast of next is null, then these are the termination condition for our loop. So I will discuss one more test case. It would be much more clear now. So I have a linked list 1, 2, 3. It has 7 elements. Okay, 6, 5, 6, and 7. Okay, so at the starting, slow will pointing to the first element, fast will pointing also pointing to the head of the node. Slow move one step, fast move two step. Slow move one step, fast move two step. Slow move one step, fast move two step. So our fast is pointing to the last node, and when the fast of next equals to null, it is a termination condition. And when the fast is also pointing to null, these two are a termination condition. So we'll stop our loop and we'll return the value of the slow pointer. And we can see this is our middle of the linked list because it is present at the middle of the linked list, because at the left side it has 3 elements, at the right side it has 3 elements. So this is the approach we apply to solve the problem. Now we'll look at the code to understand it further. So I have previously submitted this code, middle of the linked list. So the starting, we have two pointers, slow and fast. They are both pointing to the head of the linked list. We use a loop, and in the loop we have specified the condition until our fast pointer become null or our fast of next become equals to null, we'll make the slow pointer move one step and fast pointer move two steps, and at the end we'll return the slow pointer. Okay, so this is how we solve. This is the optimal solution, or the two pointer solution, what we can say, to solve the problem, the middle of the linked list. If you have any doubt, feel free to ask in the comments. Bye.